Hello, welcome to lesson 2.4, solving linear equations. Today we're going to do 3 examples. These examples are going to correspond with homework problems 7, homework problem 11, and homework problem 12. The good news about this lesson is that if you had a lot of success with the last 2 lessons, lesson 2.2 and 2.3, this lesson should be a breeze. If you struggled a little bit with the last 2 lessons, then this will be a good way to get caught up. The first problem that we're going to do today is going to correspond with homework problem 7. In our notes, I'm going to call this example A. A is honestly no different than any problem we did in lesson 2.2 and 2.3. What makes it different is it's going to have a couple fractions in it, and I'm going to show you a quick way to get rid of fractions. The example will be 3/10, so 3 over 10, x minus 2/5 equals 2. Now, if you're using a calculator, you honestly don't have to get rid of the fractions. But if you don't like fractions, there is a quick and easy way to completely get rid of both of the fractions in this problem. The first thing we need to do is we need to take a look at the denominators of these fractions. So in this problem, we need to take a look at the 10 and the 5. The 10 and the 5 are the denominators. What we need to do, if we want to eliminate these fractions, is we need to come up with a common denominator. We need to find a number that both 5 and 10 go into evenly. Though there are several numbers that 5 and 10 go into evenly, the first number that comes to mind is 10. So what we're going to do is we're going to put parentheses around the entire problem, and we're going to multiply each term, all 3 terms, not just one. We're going to multiply all 3. This term, and the 2. Don't forget a 2. This is a common mistake that students make. We're going to multiply all terms by 10. So let's begin. Well, 2 times 10 is 20. 2/5 times 10 is 4. And finally, 3/10 times 10 is 3. By simply multiplying by a common denominator, we took a problem that had 2 pesky fractions in it and completely eliminated them. Now all we need to do is drop down the remaining parts. So let's begin by dropping down the x, the subtraction sign, and the equal sign. Now we can solve this problem just like we did when we were doing lessons 2.2 and 2.3. Let's draw a line down the center to separate both the left and the right hand side. We have 2 terms we need to move. We need to move the 3 and the -4. As you learned last week, we always move the number that is not with the variable first. So in this problem, we're going to move the -4. So since it's -4, the inverse operation would be +4. -4 plus 4 is 0, so those 2 terms will cancel one another out. 20 plus 4 is 24. Let's drop down our remaining terms. We can bring down this 3x. Anytime you have a number pushed right up next to a variable, let's remember that that's a multiplication problem. So since this is a multiplication problem, the inverse operation would be division. We'll divide both sides by 3. 3 divided by 3 will cancel out, and we're left with x equals 8. And that would be our final answer. Again, let me stress that you can completely do this problem without eliminating the fractions. But if you're the type of person that doesn't like fractions, or maybe if you're not able to use a calculator, this is a great process to set up the problem so you don't have to worry about fractions. Just come up with a common denominator and multiply all the terms by that number, and that will eliminate your fractions. The next two problems are going to be two unique cases that you're going to see from time to time. They don't happen very often, but when they do, it's important to recognize them. So, let's begin with example B, which corresponds to homework problem 11. Example B is 7x minus 5 equals 7 times the quantity x plus 1. Looking at this problem, you'll probably see absolutely nothing different than the typical problems we've been working. And you'll begin this problem the same way you would begin a typical problem. So let's draw a line down the center of our equal sign, separating the problems to the left and the right side. As we did the other day, I would like for you to totally forget about the right-hand side of the problem. Let's look at the left-hand side and see if there's anything we can do. 7x minus 5. There's no distributing, and 7x minus 5 are not like terms. So we can say that side is simplified. Next, let's completely forget about this side. We look at this side, and the first thing we notice is that there is a set of parentheses which just screams we have to distribute. So we're going to distribute the 7 to the x, and we're going to distribute the 7 to the 1. Now when we distribute, we multiply, so 7 times x is 7x, and 7 times 1 is 7. There we go. So let's uncover this now and drop down the remainder of our problem. So 7x minus 5, and don't forget to drop down the equal sign. So we've simplified the problem. The next thing that we need to look for is, can we isolate the variable? And in this particular problem, we cannot. And the reason why we cannot is because we have variables on both sides. And that's a big no-no. So as we did the other day, our first step, once we've simplified, is to get these variables on the same side. It does not matter which one you move, so we'll just pick one. I'll go ahead and choose, let's move this x on the left-hand side. Since it's positive x, and again, don't forget, it's a common mistake, this minus sign goes with the 5, not the x. So this is positive x. So we're going to subtract x. We subtract it from this side, and we'll subtract it from this side. 7x minus 7x cancels out. And look what happens. Here's the unique part. 7x minus 7x on this side also cancels out. So what we're left with is negative 5 equals 7. The variables are completely gone. There are no variables left in this problem. And we're left with a statement that is completely false. Negative 5 absolutely does not equal positive 7. It never has, it never will. So what we can say is there is no solution to this problem. That means absolutely no number can make this problem true. You simply write down no solution and you go to the next problem. On to our final example. This example we'll call problem or example C will correspond to homework problem 12 in your homework. For this example, let's use the problem negative 5 times the quantity 2x minus 4 close parentheses plus 4 equals negative 10x plus 24. I picked this problem because there's a lot going on, and it'll be a good test to see if you've picked up what we've learned over the last couple days. So let's begin by always drawing a line, splitting this problem into two. Okay, let's begin by looking at the left-hand side of this problem. So I'm going to box this out for a second. We've got a lot going on over here, but hopefully the first thing that we notice is we've got a set of parentheses, and anytime we have parentheses, we should look for the distributive property. So we're going to distribute this negative 5 to both terms inside the parentheses. So we'll go negative 5 times 2x, and we'll go negative 5 times negative 4. Negative 5 times 2x is negative 10x. Negative 5 times negative 4 is positive 20. And then we just drop down this plus 4 on the right-hand side of this particular problem. So we're not done. A lot of people would like to go on and start moving things to the other side of the equal sign, but we are not done. We have like terms. Positive 20 and positive 4 are definitely like terms. 20 plus 4 is 24. Let's drop down the plus symbol, and let's drop down the negative 10x. We've got this problem as simplified as possible on the left-hand side. Let's drop down our equal sign. Let's get rid of that box, and let's drop this down. So we've got negative 10x plus 24. Now you might notice something really special happened in this problem, and like I said, it doesn't happen very often. But take a second and see if you notice anything special that's happened in this problem. And to make it a little bit easier, what I'll do is I'll cover up the top part of the problem so we can just focus on this part. So let's forget that's there, and let's look at this part of the problem. What do you notice about this problem? What do you notice happened? If you said that both sides are completely identical, you're exactly right. And let's watch what happens if we continue this problem. We have variables on both sides. We have minus 10x's on both sides, so let's pick one. It doesn't matter. And let's do the opposite. Since it's minus 10, we will do plus 10x and plus 10x. Negative 10x plus positive 10x cancels out, and negative 10x plus positive 10x cancels out. We are left with 24 equals 24. Now this is similar to our last problem in the fact that the variable completely disappeared, but the only difference, and a very big difference, is that we have a true statement. 24 does equal 24. 24 always equals 24. So what we can say is our answer to this problem is all real numbers. That means any number would make this problem true. You could substitute in 100, negative 17, 3.5, negative 3/4. No matter what you substitute in for x at the beginning of this problem would make it a true statement. So in conclusion, to wrap this lesson up, most problems will have one solution. Typically you'll get an answer like x equals 10 or x equals 1/2. But occasionally you'll get a unique situation where the variables will completely be eliminated, and in those cases, if you end up with a false statement like 17 equals 4, your answer is no solution. And if you end up with a true statement like 3 equals 3, your answer is all real numbers. This concludes the lesson. You should be ready to do your homework. Good luck.